Everyone thinks a crowded room swallows sound. They're wrong. It's what the room is made of that decides whether your voice dies or echoes forever. Stand in your kitchen and clap. Now stand in an empty auditorium and clap again. The second sound lingers, it bounces, it fills the space with itself. But why? The answer isn't about how many people are listening, it's about what's listening. Your voice is a vibration. When you speak, your vocal cords shake the air around them. That vibration travels outward in all directions at about 125 feet per second. It's fast, it's relentless. But the moment it hits a surface, something unexpected happens. Some surfaces are greedy, they absorb sound. A curtain does this. So does a person. Human bodies, skin, clothes, hair, they are all tiny sound sponges. When your voice hits a crowd, most of that energy doesn't bounce back. It gets trapped. But an empty room is different. The walls are hard, drywall, plaster, concrete, wood, they are reflective. When sound hits them, it doesn't vanish. It bounces back, and then it bounces again and again. This is reverberation. The empty room doesn't make your voice louder, it makes it linger. It amplifies the time your voice stays in the air, not the volume itself. But to your ear, lingering sounds louder. The brain hears richness. It hears presence. Now here's where it gets interesting. Scientists have known this for centuries, but they didn't always know why it mattered. In the early 1900s, a man named Wallace Clement Sabine was asked to fix a problem that nobody else understood. Sabine was a physicist at Harvard. He'd been hired to fix the acoustics of a lecture hall. But here's what Sabine didn't know yet. There was no mathematical formula for how sound behaves in rooms. None existed. He was walking into a mystery. The lecture hall was nearly unusable. When a professor spoke, the words echoed so badly that students couldn't understand anything. The sound was trapped, bouncing endlessly off hard surfaces. Sabine needed to kill the reverb, but how? So Sabine started experimenting. He'd sit in the hall at different times. He'd bring in cushions, blankets, curtains. He'd move them around. Then he'd listen. He was measuring sound the only way he knew how, with his own ears. Over months, a pattern emerged. Each time he added absorbing material, the echo got shorter. He realized the problem wasn't the room itself. It was the ratio of hard surfaces to soft ones. Balance mattered. By 1900, Sabine had created the first mathematical model for room acoustics. It's called the Sabine equation, and it works. It's still used today by architects, recording studios, and concert halls, all because one man sat in an empty room and listened. So what does this mean for you? The next time you're in an empty bathroom singing and you sound amazing, you now know the truth. You're not a better singer. You're hearing the physics of reflection and absorption at work. And when you're in a crowded restaurant struggling to hear your friend across the table, the room is doing exactly what it should. Hundreds of bodies are absorbing sound. The hard surfaces that remain are scattered. Chaos is the natural state. The empty room isn't magical, it's just honest. It shows you exactly what your voice does when nothing gets in the way. It travels, it bounces, it persists, and that persistence is what we hear as echo. This is why concert halls matter, why recording studios have special walls, why a cathedral feels different from a closet. Physics is everywhere. It's in the spaces we move through every single day. You've been living inside acoustics your whole life without naming it, without understanding it. But now you do. The next time you step into an empty room and hear your voice travel, you'll know exactly what's happening. You'll hear the science. Subscribe so you don't miss the next everyday mystery, the hidden physics hiding in plain sight, waiting for you to notice it. Subscribe so you don't miss the next everyday mystery, the hidden physics hiding in plain sight, waiting for you to notice it.